We have 8 teams presenting today, and the teams are 3 or 2 students, and they've been working through the entire semester on their projects, and we're looking forward to them because we haven't seen the final products yet, of course. Ming is a lecturer in the computer science department. I'm a lecturer in the music department, and the 2 of us have been teaching this course. This is now our 3rd time teaching the course, and it just gets better. This year we have had an especially good time with the course because of these 2 gentlemen, Chris Penny and Connor Taylor, who are both seniors, and they devised a new way of working with the programming languages to do iOS development, which I don't think anyone has ever tried before, which is that they've been using a programming language called PD, or Pure Data, which is an open source language, a graphically oriented open source language for doing music applications on desktop computers or laptop computers. And they have been working with a library that they discovered called Library PD, libpd, which is also open source, and they've been working with linking that to Apple's development language for iOS called Swift. And so the students have been able to work in a much more friendly, much more creative, much more feedback-oriented environment than they have in the past. And this, I think, has contributed greatly to the complexity, the cleverness, and the usability of all their applications. So our hats are off to these 2 gentlemen because they did all the work.
My name is Ruben.
I'm Bradley.
We have developed the application Fretless. An issue with a lot of electronic instruments, especially ones that communicate via MIDI, is that you basically send a note. No matter what, it's going to be in tune. However, the point of our app is to simulate some fretless instruments so that you can get between notes pitch-wise and also have other dimensions or parameters. Left to right is pitch, frequency. Scale between the values.
Yeah, and up and down is effects. So right now we have a filter on the frequency as you go up and down.
Our app is also multi-touch. So, the effects can be changed in our little, we have some hidden menus that open on the sides. If you don't want it to be filter, let's say you want it to be LFO, also on the filter cutoff. Each finger can change the effect parameter independently of the other fingers.
So you can control volume going up and down. We also have choices of different waveforms too. So we have 9 different waveforms that we just made up.
There are lines that go through each of the note names. We have an edit mode option, which what you can do is, in this mode, let's say you want to play your app, but you don't want to have G in there. So you don't want to ever, I mean, you'll still, theoretically can hit the frequency of G, but you can double tap out notes.
It's pretty cool.
So that you can
also swap.
You can also swap.
We also have basic navigation. That's what the arrows are. The small arrows are half steps in the respective directions, and the large arrows are octaves. And we also have some other cool theme stuff that we put in, so you can change the colors.
People like colors,
Kind of fancy. Right. And one of the other cool bonus features we put in were the ability to add different layouts. So right now you're seeing the piano layout like a typical piano. We also have grid.
So in this layout, the frequency values are still scaled left to right, and then the effects values are up to down within each box. So one of the important things about when you swap notes and rearrange notes is that it keeps the frequency scaling consistent.
These 3 sliders control attack, decay, and release. Yeah. So you can change your
right
waveform parameters.
Yeah, this is just like long attack, short attack.
And then the last big feature of this app is our looper. So we have the ability to record notes and play them back on a loop. So do a few bars. So you can see the track has been added.
you decide you record a layer that you like, and then you record another layer, you're like, oh, I really messed that one up, but I don't want to delete my whole loop, you can actually delete individual tracks.
So we're Team Touchstone coming back at you.
Right now we have play mode. It launches into a basic scale that you can play. You can tap them, you can drag through them. Right now we have it set to sound like a grand piano as our default sound setting. If we want to change up the notes, we can go into edit mode and we can delete notes if we want to. We can clear the entire screen if we want to start over. We can delete all the notes. And then you can add scales of different octaves. You can have sharps or flats. You can choose the color of your notes. You can position them in a way that's useful for you to use as a musician. You can also add single notes if you're really looking to personalize it a lot. And then you can go back to play mode once you've done this and play. After I add a note, I can hide the edit bar and move it around down there. And that way I can use the full screen. Say you've spent a lot of time on your note layout, you really like it. What you can do is you can hit the floppy disk icon at the top and you can save the layout.
Another big feature that we tried to implement is the sequencer that you can see at the bottom. So the way it works is that you could set what time signature you want at the bottom. You could set how many beats per minute. I could choose whether I want a metronome or not. And when I press the record button, I can play whatever I want to. And you can play it back. You can pause in the middle. You can press back and start over. And with this particular layout, there isn't that much that I want to play, but we actually saved a layout that's good for recording something, so I'm going to play a little song for you guys. This sounds good with banjo. Okay. So I'm going to do this a few times. Okay, so I have that, and if I want to, you can also change up the speed in playback if you want. It'll work like that.
We have some presets that you can choose and demo with the test note. And then so with any of these patches, you can then change the effects any way you want. So first we have pitch tuning, so you can change the octave so that all of the notes are up 2 octaves. You can fine tune it with the fine slider, so you can get very small changes in pitch. We also have a high pass, low pass, and band pass filter. So if we want a low pass filter, we can turn the cutoff frequency down and the resonance way up. Get sort of neat sound. And then we also have some basic effects. We went for simplicity as far as the delay, reverb, chorus, and tremolo. We wanted the user to be able to get changes right away. So if we decide to add a large amount of delay, that's actually the time. That's the time between the notes. And then one more feature of our app then is the ability to stack notes and play chords.
I'm Sam.
I'm Justin.
I'm Brian.
So yeah, this is Sound Stories. I know that almost all my experience of looking at people who are using an iPad are almost always children. So we wanted to take that ability so that we could take music and technology and the iPad to children. So we created essentially what we call it is a musical sticker book. So you see the basic screen here, options up at the top, and Sam, why don't you put those two together? So yeah, here are a couple stickers. Each of them have their own musical phrase. Yep, and you can make them bigger or smaller. So you got a really big fat pig and a little dog. And then you can also switch scenarios. So if we wanted to go to a castle, it clears it. And then you have another whole slew of characters, like a princess and an ogre, and a dragon, and also a different sound font. This one is a trumpet. Playing from left to right. So you can create a little musical story.
You can delete any character you like, so you don't like the dragon anymore. You can just get rid of
You touched it first.
him. Have his little goodbye song.
But something that we added is that if you see the little sun right here, each of these are their own effect. So for example, the sun is tremolo. So just by placing the sun in the screen, everything will play with tremolo. And if you add the cloud, that's reverb. And if you add these shooting star things that we thought were applicable in each scenario, it is chorus.
Who did the art?
Google. It's really good for interval training, actually. So if like you wanted to start teaching kids like rudimentary music theory to learn about what's the difference between a minor third and a major third, that could easily be done with phrases, and it's something that we.
And the other thing is, by stacking phrases on top of each other, it's actually like a beginning composition exercise.
Right.
You're learning how to put together a phrase that sounds like a whole phrase, and then a song that sounds like a whole collection of phrases,
And learning like what doesn't sound good and what does sound good. Something else we realize is that oftentimes when children are playing with things, they want to put what they're like drawing something, they want to put themselves in it. They'll draw themselves. So we added something else. Everyone smile. And then this will come up and you can record something. I love music apps.
wow,
And then
great.
yes. I love music apps. And you can play that within the song. I love music apps. I love music apps. And you press the volume button. You get a special C rating.
So I know we've all had that thought, like, don't you wish you just had a theremin for yourself to bring everywhere? We just did the y-axis as your kind of distance up the theremin, and then your x-axis as the actual pitch itself. Yep. Exactly. An octave switch that Thomas demonstrated by sliding, and also by touching the arrows that slide it an octave. And then we also implemented grid lines that can give you even more precision when you're traveling across the theremin.
Diatonic quantization.
We've implemented up to 10 touches.
Which is a little interesting for a theremin, but it could also be extremely useful on an actual version. At the bottom have a number of effects that you can alter with this knob. As well as the ability to change what is actually affected on the y-axis. So if you want to apply, tremolo.
And you can do different ones for each touch. Or vibrato if you want.
Another big feature that we implemented was the ability to record.
Essentially what we have there is a fully functioning looper pedal for theremin. We decided against the sequencer form because it gave us a little bit more freedom of expression.
Music.
Right now we're doing a sine wave, but or close to a sine wave, but I can change it to a nice square-like thing. I can also pop in another oscillator here and just select a wave for it. We'll give a sine. And I can change the pitch of that one if I want. And we can even pop in another oscillator if we want to get real fancy. And let's go with a Sawtooth.
The big idea behind this was just make something that someone who is very unmusically inclined can really get their hands on and make something that sounds pretty cool really quickly. We achieved that through taking a geometric shape and sort of tying musical relationships to that geometry. So if you get like a C, for example, you then have your third, fifth, and seventh. And then if you walk all the way around the shape with the entire scale, although on the right-hand side you can change the what key it's in, as well as going major versus minor. So the sequencer ultimately is probably like the primary functionality of this, what someone would use to work on really fast. You have 4 different options for sounds and 4 different styles. So if you want to do jazz, for example, on an 808 drum kit, and you complain because the drummer's really stiff, you could turn up the swing. Yeah, for example. But then you can also loop other sounds. So say you go to the flute, you hit record. So then it sort of automatically corrects what you were doing. And then if you were to switch to a different instrument, you can also play effects in real time thanks to the view controller popping out and staying out. Yeah, so that just creates very, very strange potential.
Basically, the idea is it allows you to quickly create a custom backing track to play along with when you're practicing. So the idea of this is you can quickly throw together a backing track and then play along with it, with your own instrument or with the instrument in the app. So you open up the app, we go to the screen set backing track, and we have some options here. So this picker view lets us pick how long our progression is going to be. Right now we have options 12 and 16 bars. You pick the feel, which ultimately will determine what rhythmic pattern the backing track instruments will have. Just pick some chords and you pop them into that slider view down there. So we pick a chord, then we just click the box and it goes in there. So we fill in our stuff here, and then we go to F. Yeah, you'll see there. Some more F's and stuff. G's. Gotta have the G's. So now we click set backing track. And that's been saved into memory. And then if we hit play, change it.
Can you sing over it?
I'm not going to now. And then we can pause.
So pause like freezes it in time. If you hit stop, it resets it back to the
Keep going, right? Or stop. So the other feature is then we can add notes.
So we've got a full piano here. Well, not full, but the way it works is you just tap the notes for the ones that you would like to use. And so they appear right here. We have some visual feedback here when we play our notes. And then we can go.
You have like vibrato, which we start at 0. You can go like faster if you want. And then our last main feature is that if you're playing your backing track, you can make it faster and slower. Yeah, then we have a help screen, which just tells you.
And you can go to the different screens.
Pocket Orchestra was born of the idea that music is better when you have multiple instruments all playing together. Whether that's just you playing by yourself with a set of instruments that you can play all at once, or playing with friends, it's important to be able to collaborate between multiple different voices and multiple different instruments in order to enjoy music and to sort of develop your own musical abilities. So to accomplish this end, we have created Pocket Orchestra, a 4-in-1 jazz quartet with all of the major components that you need in order to play music collaboratively together.
All of these are valves that you can pull open, and so with each note, you can either pull it open and it'll sustain, or you can reset the valves, or just simply tap a note and it will play off. If you're familiar with Fruity Loops, this will make a lot of sense to you. Effectively, we have 16 notes that go across, and you can see each of the different drums that we have here. This is for the drum here, so let's just do a quick little...
This interface supports multi-touch and swiping, so you could just take 3 fingers and swipe all the way across the cowbell and something else, and you would get. There we go.
Also, we have the same thing for the bass over here. So what were we doing before? C. I believe it was C.
That looks about right.
What you just saw was Joe setting up a percussion pattern that then continued when we switched into the bass view, and so you can build up your drum and then your bass, and then you can set up your chords and then have all 3 of those going as you solo on the lead instrument.
Now, of course, one of our key goals was the ability to collaborate not just with yourself, but with others. And to accomplish this, we have set up a system by which other players can join in on melodic instruments via Bluetooth. I'm going to play a melody from my iPad, and it will seamlessly integrate with what Joe is doing on his. And then we connect with a tap of a button, and then as soon as Joe clicks receive, we have the ability to play on 2 different iPads, but with one interface. Yeah. So we have the ability now to collaborate as a group so that multiple people can all get together with their iPads and make music together. Which should, of course, be the goal of any musician, is to make music with others. One of the big goals that we have from here is to actually integrate the Bluetooth functionality with other music apps so that, for instance, I could make an iPhone app that just had a single instrument in it that only worked as a controller for our Pocket Orchestra collaborative space.
The entire application is actually outputting MIDI. Originally, we were communicating with pure data through bangs and strings and floats. Now everything's set in pure MIDI, so if you actually want to set a different endpoint to it, you can send it to anything that can read MIDI.
Which also means, in theory, that you can actually use our app from a collaborative perspective, use it with any interface that accepts Apple's Bluetooth MIDI format. Specifically, I think GarageBand and other Apple-centric music suites can support that.
For our application, we tried to implement pure data on the iPad. So we got pretty far. There are still a few things that we wanted to get in there that we just didn't really have the time to, but for all intents and purposes, we can actually develop pure data patches on the iPad. This will give you a little bit of a taste of what pure data actually looks like, and from there we'll explain why we kind of made the decisions we did and then where we'd like to go with this in the future.
So basically you open up, you got your canvas right here, and here I'll go ahead and add a little bang button on there so you can see what's going on. We have this whole canvas we're working on. You can shrink it pretty small, you can add things all around on it, and really go into as much detail as you want, and then lock it when you're done. Basically we're using a pure data patch that implements pure data. So the pure data itself has some scripting capabilities, and we essentially were able to make a wrapper for that to turn pure data into full-fledged scripting language, which we then use as the backend. So like here we have 2 bang buttons right now. The most basic patch you can make is 2 bangs that then bang each other. With pure data on the computer, you have your mouse, and you can easily go over a very small connector and drag a line. Over the iPad, it's a little trickier in terms of using touches. So we actually did a separate connection mode. So you have the normal cursor, which you move it around, and then when you're ready to connect things, I'll just drag another button on here, go into connect mode, and wire them up. Of course, you actually have to still end on the connector. Just like normal pure data, you have an edit mode and a play mode. So I'm going to go out of that into play mode, and you can see when I tap these buttons, the other 2 tap. It's exactly what you'd expect. We have all the objects in vanilla here in the sidebar. So we have the GUI objects on the side that you can just drag over. We have a bang, we have a number. Got a message box, But if you want to actually add these, essentially you have this convenient little library. So I'm going to add an OSC and scroll right down to the O. There we go. You can select it and then double tap, so you can make a couple of them if you want pretty easily. And then let's make a deck. So right now we're in edit mode. I'm going to go into connect mode, wire this up. So right now we have an OSC at 0 frequency. So let's change that so it's actually playing something. I'm just going to wire this little number box that we got, put it down here so we have plenty of room to scroll. So I go back out of the edit mode into play mode. Okay.
Oh, come in Moscow.
Okay, well, so now you can see I'm changing the number, and that's changing, connected to the OSC frequency. One of the things we learned, especially with this app, implementing pure data for the iPad is a massive undertaking. So really, it was about figuring out what steps are just needed.
Our main goal was to try and get it so that like all of the vanilla PD objects were there and we could play with them, and then from there try and go forward and add in more extra functionality.
For every single object, we have a whole description of inlets and outlets and what they do. In this properties, we have the inlets on the left and outlets on the left, and so you can select a new thing. So I just select the OSC, and it says description, left inlet is set frequency. Then set phase, you can hit phaser, that tells you what that's doing, same as set frequency.
Did you write those yourself, or are you pulling them from?
I wrote all of them
Help
myself.
page? Okay.
There's over like 2,500 lines of code, and some late nights. Yep. Also, another interesting feature is on the pure data side, you can read in a patch and basically load it, and you can also save a patch.
But it's compatible with patches that you've created on another platform.
Right, and that's the great thing, is because with PD, the file format is just a text file. So we can just write a new text file based on this representation.
That's one of the nice things about it, is that since it's just plain text, it's very compatible on other systems. So you can use this on Android. I know that there's a lot of other wrappers, like I know you can write Python programs with this. I think there's a C# and plenty of other languages that have bindings for pure data. So if you want, you can use this as like an audio backend for pretty much any kind of application. And that kind of portability is really nice because you don't have to rewrite your audio logic for every kind of platform that you're trying to support.
Yeah.